Next topic, salts. When we talk about salts, we're talking about any specific nutrient contained in the water that's at a level that's too high for the plant. And so it's excess and it needs to be leached out. Now, a lot of times this can be sodium or chloride, but it can also be things like calcium or sulfur, essential plant nutrients, but their concentration tends to be too high. So if you look at the fate of a fertilizer that's applied to a crop, there's either plant uptake, you leach it out, or it remains in the pot. So if the salt levels in the water are too high and they remain in the pot, the EC gets too high, and you run into soluble salt problems. So you end up having to leach. So what we're going to talk about next is leaching. So if you look around the country, before I talk about leaching, let's talk about salt concentration. These are the sodium concentrations, average sodium concentrations in the U.S. It can range from an average of 13 parts per million for the overall U.S., for example, 8, 9, 10 parts per million. You go to California, Texas, arid states, they tend to be much higher. In fact, you can find locations where they're significantly higher than that. For example, around Toledo, Ohio, the parts per million sodium in the water can get up to 120 parts per million. At those types of levels, growers have salt problems, and they need to leach. Now, leaching affects not only salt concentrations, but also essential nutrients like nitrogen and phosphorus. This is work from Mark Ulanich and John Birnbaum, where they looked at leaching rates and nitrogen concentrations. If you start in the lower left-hand corner, those plants received 100 parts per million nitrogen and had roughly 0 leaching. Now, if you go to the upper right, those plants received 400 parts per million, but they had 40 to 60% leaching. Now, the ones on the lower left, the EC of the media and the plants in the lower left was similar to the EC in the plants in the upper right. So what you end up with is similar nitrogen concentrations with 400 parts per million and lots of leaching, or 100 parts per million and very little leaching. This is also work from Mark Ulanich and John Birnbaum. They looked at container capacities leached on the plant and then how much of the nitrogen applied was leached out. If you go to 25% containers capacity leached, so 25%, roughly 25% leaching fraction, around 50% of the total nitrogen applied was leached out of the bottom of the pot. So if you combine those two aspects, if you have high salt, then you must leach. It means that you have to increase the fertilizer concentration you're using to maintain adequate nitrogen levels in the pot. So if you have high salts, you have to use more fertilizer and you have to leach more. So again, if you look at the crop or look at the poinsettia crop, as leaching rates increase, the fertilizer concentration applied must also increase to compensate for the loss of nutrients. So to manage high salts, you have to leach and you have to use higher fertilizer concentrations.